Because lesson 5 talks about using sampling to predict. So what we're going to learn in this lesson is to determine the validity of a sample and predict the actions of a larger group. So in order to do that, the first thing we want to talk about is biased versus unbiased samples. So you'll see on your first page here, we have some examples of unbiased samples, and then we have some examples of biased samples. Now you notice there are some specific names in each of these graphs, definitions, and examples. You do not need to learn all of these different biased and unbiased. I just wanted you to have them for reference, so if you're not sure if something would be biased or unbiased, you could hopefully go through and find an example that it matches, and then you'd be able to look at the top and see if it's unbiased or biased. Okay, so we're basically just going to skip that first page. Again, look back through it, read it over, give yourself some examples. But then we're going to start here. So on the next page, suppose a school conducted a survey about new clubs. They cannot survey every student, so a randomly selected smaller group called a sample is chosen from a larger group or population. So sample is a small group, population is the whole group. Then the best sample is an unbiased sample, or one that is, so in order for it to be unbiased, we need it to be representative of the larger population. It needs to be selected at random or without preference. It needs to be large enough to provide accurate data. So if a sample is too small, data accurately representing the larger population may not be available. So the biggest thing that we're looking for here is it random? In order for it to be unbiased, we're looking for is it random and does it represent the large population? So down here, a sample that is not representative of the population is called a biased sample. A biased sample usually favors certain parts of the population over others. So it's not random, or it kind of leans towards one specific group over everybody else. All right, now that we know what unbiased and biased mean, let's determine what we think about these upcoming examples. So to determine the types of music a concert hall's customers like best, all the people attending a country music concert are surveyed. Identify the sample as biased or unbiased. So we want to decide, is it random and does it represent the entire population? Well, you'll notice they're sampling people at a country music concert. So we're going to say it is biased because if they are at a country concert, they probably favor country music. So it's not representative of the entire population, and it's not completely random either. So again, it's biased because if they're at a country concert, they probably prefer country music. Okay? Let's take a look at the next one. A pet store mailed a survey to residents to determine their favorite pets. 50 people responded, and the results are shown on the table. Is this sampling method valid? And if so, how many people can you expect to choose dogs as their favorite pet in the city with 1,585 people? Explain your answer. So you'll notice, survey sent out to everybody, but only 50 people responded. So we're going to say that this is not valid because only 50 responded. You have no idea who those 50 people are. If we could have 1,000 people out of that 1,585 that prefer dogs, but only 50 people responded. So again, it's not a large enough data set, and it's not completely random because they are choosing whether to respond or not. So it's not random because they choose. So it wouldn't be like walking down the street and randomly asking every 5th person that you saw. So again, not random because they choose if they respond, and when it's not random, that makes it biased or not valid. Okay, so we have another example here. From a batch of 7,500 computer chips produced, the manufacturer sampled every 150th chip at random for defects and found that 2 were defective. Is this sampling method valid? If so, find how many of the 7,500 computer chips you can expect to be defective and explain. Okay, so out of that 7,500, every 150th chip is randomly selected. So we are going in a ordered manner here. Every 150th chip that goes through is tested. Even though it's an order, it's still random because you don't know when that or which one will be the 150th one. That just randomly happens to be number 150, number 300, number 450, etc., etc. So yes, it is valid. And if you went back through, if you weren't sure about this one, if we checked out our unbiased sample, your systematic random sample would be the last one in that chart. Tells us an example that is similar to this one. So yes, it is valid. Yes, it is unbiased. It's a D there. Okay, so now that it is valid, we want to use this information to decide how many of that 7,500 computer chips would be defective. So first off, if I have 7,500 and every 150th is chosen, I want to find out how many times is that going to happen. So out of that 7,500, if we divide this, you'll find that 50 of them were tested. So 50 total chips would be tested. And we see that 2 of them were defective. So that tells me 2 out of every 50, which if we divide that, we get 0.04, which is 4%. So we can predict that 4% of our computer chips are defective. So what then is 4% of 7,500? You could either do your proportion or you could just multiply 0.04 times 7,500. It gives us 300. So we would predict that 300 chips are defective. Okay, so we decided that yes, it was valid. Given that it was valid, we found that we're checking every 150th chips, so that means we checked 50 chips total. So if 2 out of the 50 were defective, that tells us that 4% of our total chips are defective. So we can predict then that 4% of 7,500, which is 300, are defective. All right, now on this last slide here, the try it out, we want to identify each sample as biased or unbiased. You do not need to describe its type. And then for the explain your reasoning, all I will be checking for tomorrow is that you write biased or unbiased on each one, but then I want you to be able to explain why you chose biased or unbiased. I will call on random people to answer this, so make sure you know why you wrote biased or unbiased. All right, that's the end of this lesson.